This symposium is about the future of computing research. And, if we think about the future, nothing's really more important to the future than the people who really are that future. So we've convened this roundtable to hear from some of the best and the brightest, and I think you're really going to find some of the most incredibly interesting early career professionals who, through their research, are paving the way for the future of what computing is going to be.
So we have brought them together to have a conversation today about what drew them to the field of computing and what they think will sustain them in the field and how they think the field needs to advance to enable their vision of the future. And we're really pleased to be able to listen in on such a conversation. So let's get started. We now ask each of our roundtable panelists to briefly introduce themselves, beginning with Gabe.
Hello, I'm Gabe Kapshuk. I'm research faculty at Boston University in the Department of Computer Science. And generally, the stuff that I study is privacy in all of its varied forms. In particular, my main computing area is applied cryptography. And so I do designing of privacy-preserving protocols, stuff like secure multi-party computation and zero knowledge. And kind of any kind of design of something that's ultimately going to give an end user some privacy. But for me, the interesting part about doing all this mathematics is about getting these tools into the hands of actual end users and empowering users to give themselves control over their own data and build some privacy, fight against surveillance capitalism, and make the world a slightly better place. My work crosses from theory into practice into human interaction, and kind of taking all those things to try and make the world even just a little bit better.
All right, awesome. All right, hello everyone. I am Dr. Jasmine Berry. I am a NSFCI research fellow at the University of Michigan, working on applications of theory of mind for socially assistive robotic systems. I also work closely with health tech companies to implement precision health and wellness platforms using machine learning and data science. Most notably, I do this within the areas of biotech and sports science. And my research focus is within the umbrella of neural AI and brain theory, which is an area that we hypothesize how neuroscience may provide foundations and infrastructure for how we can build the next revolution of AI systems, and in turn how those new AI systems can help us learn more about our bodies and physiology. So a lot of that particular research focus in and of itself that I'm focusing on right now is related to the formations of identity and a formation of self within robotic agents that we're often using in the lab that I'm currently in. I'll pass it off to Jonathan.
Excellent. I'm Jonathan Frankel. I'm about 4 weeks away from defending my dissertation at MIT, so I guess I can still say I'm a PhD student there. I'll be starting as a faculty member at Harvard a year from now in engineering, and I'm working on a startup based on my soon-to-be completed dissertation in the meantime. I work in machine learning, but I work in machine learning with a bit of a weird angle, which is that I'm a very, very strict empiricist. I question the fact that in computer science, we often learn via proofs first, and we try to build our foundations from theory up. And in large-scale complex machine learning systems, that I don't think that infrastructure necessarily, is going to help us climb all the way up to actually getting understanding of these systems. And instead, we may have to treat them more like biological or any kind of natural system where we look at empiricism first and then put the pieces together from there. This has gotten me into trouble a little bit on the faculty market, but it's definitely made me think a lot more about our colleagues, in HCI and networking and any kind of web science, who are thinking about real world systems and have to measure, and how we broaden computer science to really embrace those sorts of approaches as foundations of knowledge.
Hi everyone, my name is Lane Jackson Hubbard, and I am fortunate to be a Computing Innovation Fellow at the University of California, Irvine. I work in human-computer interaction and specifically designing for early childhood. And so I collaborate with early childhood media groups and advocacy groups to design interactive storytelling technologies for young children.
I'm Megan Hoffman. I'm a senior research fellow at Northeastern University. I'll be starting as an assistant professor of computer science and mechanical engineering at the Corey College of Computer Science next year. My research is traditionally in the space of human-computer interaction, although I'm mostly interested in this as a venue for studying how different types of people who we don't normally think of as building technologies go about building technologies, particularly in domains like healthcare and accessibility for people with disabilities.
Hi, everyone. I'm Sam Galotra from the University of Chicago. I work broadly in the area of data management, where the goal of my research is to build trustworthy systems so that users can mine as much information as they can from the data they have. I strive to make fairness and explainability the first principles in software design so that all involved parties, which are the developers, the product owners, and the end users, can trust the system. Thank you.
Hi, everyone. My name's Tess Smith. I'm an assistant professor in electrical engineering and computer science, but all of my degrees are in physics. I'm a condensed matter computational theorist by training, and most of my research kind of surrounds how do we merge the math that we know and love and the physics that we know and love. So that kind of rigorous work there with the flexibility and the power of machine learning. And when we do that, what are some of the fun and unexpected and very useful properties that we can that we get when we do that, and how can we use that to model the natural world? I especially like to use this for understanding and designing physical systems, such as atomic systems like molecules, crystals, proteins, not only to investigate their fundamental properties, but also ask questions like, if we could make anything, what should we make, and how will we go about that?
That's great. Thank you, everyone. What a wonderful set of introductions. I'm going to kick things off with a first question for you, and that is this. Is there anything about what motivated you to pursue computing research, to pursue your PhDs, that might inform how we think about the future of computing? And it's an open mic here.
Well, let me also add, one of the things that when we were talking a little bit earlier, there are so many opportunities for all of you to do so many different things. And here you all are in academia doing research. And we wanted to hear your voices about how you came about those decisions.
So I can try and start us off. My original motivations came from the fact that as a middle schooler, I was obsessed with Star Trek. Next Generation, and I wanted to build the Starship Enterprise. And it seemed like computers were going to be involved and physics was going to be involved. So that was sort of a natural path for me. And what I see is computing representing to me as just an immense superpower. It's a fantastic way to express ideas, explore ideas, test things out. I mean, working with a computer is pretty unforgiving. You have to be pretty clear in your thoughts currently to work through things, and sometimes that process is really helpful, or sometimes someone makes a tool that just makes it so much easier to express yourself. And I think computers are really an amazing avenue for boldly going where no one's gone before. So I'll hand it off to other people.
I think in some ways I kind of have the opposite story of you, Tess. I actually kind of hated computers and did not like computing until I started my undergraduate degree. And the reason I was more attracted to it was I started to realize that this was a very widely useful tool. It would give me a lot of opportunities that understanding other things were maybe going to narrow my choices down. And this, this also reflects on how I chose the research area that I'm in. I really chose accessibility and healthcare work, not because I was particularly interested in the technical challenges there, but because I identified with the problems. I have disabilities, and those really informed a lot of the work. And the process of being a researcher in this space has actually helped me to kind of reckon with that identity as well as deal with the problems that affect my life.
Yeah, I think maybe my foundation was similar, maybe a combination between Tess and Megan. I got my start as a preschool teacher. And so I originally started studying neuroscience because I wanted to, design things that could help kids who were going through difficult times. And as I started researching neuroscience, I began to see computer science as a really great way to translate research into practice. And so that kind of got me off and running with computer science, and was lucky to have funding that allowed me to do, new things and to take ideas from being a preschool teacher and see if I could design, conversational agents that could help kids tell and talk about their own stories and needs. But yeah, I mean, Megan, I was a foster kid. And so being a researcher and designing for young children actually, for the first time, gave me a voice to talk about being a foster kid and making that really a big part of my scholarship. I wrote about that in my National Science Foundation GRFP application. And so that was really powerful to me as well, to be able to take these identities that I didn't think had anything to do with my scholarship and begin to take a lot of pride and ownership of them.
I definitely want to say I agree with Lane and saying that maybe a combination of Tess's and Megan's motivation is similar to mine as well. You know, for me, I've always had this awareness that, you know, there were a lot of health concerns in the communities that I grew up, a lot of people suffering from chronic illnesses. And for some reason that I always paid attention to it. And with my innate interest in computer science and all things tech, I wanted to see if there was a way to maybe supplement that or kind of fill in the gaps of what's missing in the medical system or the healthcare system. You know, why are people always sick? You know, why, you know, can't we extend human life and get older and not just be old, but have a high quality of life, you know, as we age? And computing was a way for me to look into that. And, you know, like Lane, I was very interested in neuroscience. I think I started becoming more interested in neuroscience when I was in undergrad, especially with my senior project. And I realized, you know, there's a definite intersection between us learning how the brain works and how we can inform what we consider the brain of the computer, which is oftentimes the AI, and create systems that can be an extension of us, a positive extension of us, and reflect the best of us in many ways. So I think when I look at what motivates me to pursue computing research, or what motivated me in the past, it did start in middle school. So I want to emphasize that this starts very early on in many boys and girls, and we need to capture that attention at a very early age. But for me, I remember just being fascinated with the opportunity to explore the unknown and to contribute to present needs that I saw right then and there. I think it's a grand opportunity. Like Tess mentioned, you know, I did like Star Trek. Thanks to my dad for getting me involved with that. But you know, also looking at you know, some of like the Jetsons, for example, I think those are key influential markers as well to get people interested in tech, because you're trying to create the future. But many people, especially the public, they're concerned about the now and the very near future, about when their kids are born in the next generation. What can they do right now to build a better environment or a social structure using computing? And sometimes that can span environment, agriculture, health, you know, politics, and you know, computing is so pervasive and ubiquitous. I think we have the opportunity to do something amazing here. And that's what motivated me. Like, how can I make a change while I'm still living and breathing, and for the future generations to come right after me?
Perhaps I feel almost unaspirational in relative to those amazing answers. I really enjoy building things. And if you can talk about a powerful medium in which you can build something extraordinarily large with very few resources that can impact a lot of people, the multiplier effect of using computing as your medium is just extraordinary. And, you know, my research, as I've, you know, become a mature researcher, not just, you know, a 12-year-old playing with HTML, is really, you know, about understanding what these materials are and what properties they have. You know, everything from, you know, research I used to do in programming languages to now working in machine learning, where we're building systems on what feels like quicksand, and we don't understand the first thing about the physics of how this material behaves. And it's a little bit terrifying to me that we don't understand it. And there's a huge opportunity to not only improve our understanding, but hopefully allow us to build better systems once we can treat it like an engineering material, not like, you know, something that we slap together and hope for the best with.
I think for me also it was something similar, that I just got into research because it was intellectually challenging. And I thought, let's just try to do a project. And I did that project, I really enjoyed it. And I tried to do more projects. And that's how I got into research. But the projects I tried to pick were topics that were dear to me. Like, for example, I observed near me that when I came to the US, the insurance rates were very different for me as compared to my friends or even the citizens. So I saw there's some kind of biases and unfairness in the system. And I was just talking to my mentor that this is what I observed. And she said, why don't you test it out in the data? And that's how I got interested in this topic. And then we started working on fairness testing. And then I realized that there are a lot of problems that are very impactful, which impact everyone on a day-to-day basis. And I got excited about those. And that's how I ended up doing a lot of research in fairness and explainability and trying to see how users perceive technology and how can we help improve that perception.
I'm really, it's so funny, like the sense of wonder that I think like conveyed in so many people's answers, like really touches home for me. I remember definitely 6th grade math day was like the day I was like, wait, that's what the internet is? Like, no way. And it just taking off from there. And at the same time, I really am not sure I ever made the choice to study computing. I think computing kind of like chose to study me a little bit. Like computing was just like a way to reason about the world around me. And it's really just a medium for me. Especially the work that I do in security and privacy is about people. It's about trust. It's about systems. It's about all these kinds of things that are going on in the world around us. And computing just happens to be like the water through which all these things flow. And so I just find myself like, I'm still not sure I really understand computing, and I'm not even sure I aspire to. I just want to somehow grab onto just enough computing to like throw it at the things that I care about. And I mean, I think I'm just echoing the things that other folks already said, the things that pop up in our own lives and that you want to throw computing at to go away a little bit. It really speaks to me. It's cool to feel that shared experience among this group of peers. That's really awesome.
It's really interesting listening to all of you. It's really clear that you were drawn to computing for different reasons when you were all pretty young, quite honestly. I think I was probably in late high school when I first even touched a computer. So you all seem to be drawn into computing. And yet when you've talked about when did you sort of think about the research side of it and the creativity side of it, it seems that came later, right? It was sort of fascinations with building things and what these machines can do, but the research side of it and that creative process, it sounds like, did that mostly come to all of you in, sometime in college or early graduate student days?
Yeah, I'll say undergrad for me. Yes, through summer REU experiences.
Oh, you were an REU, great.
Yes.
You were an NSF REU student?
I don't think it was NSF. I forgot the official sponsor, but it was an REU at UC Berkeley, and they invited you out to do research with a particular professor that you had the chance to interview with beforehand. And that was my first chance at doing research to that extent. And it really opened my eyes to the possibility of doing something that's innovative and also credible, and that you can make a slight contribution to science in some way. So that's what got it started for me.
How about others?
I think, ironically, for being one of the maybe later folks to be interested in computing, I wasn't interested until college. I also was immediately in research. From day one of taking classes, I was also doing undergraduate research opportunities at my university, and then later REUs, the same as Jasmine. And for me, that was partially because I was not actually finding the technologies that allured me to computer science being that accessible through either my courses or through just the kind of technologies that I could access in general. So I think it was the idea to build new things that were not yet there and I didn't have opportunities to access any other way was what made me really interested in research.
My parents always told me that, if I had been born 30 years earlier, I would have been working on cars as a teenager or something like that. And it just so happened that computing was accessible enough that I could get interested in it. And it, when I look forward on that, I think about the undergrads who I supervise today, or even high schoolers who I see, they're all playing around with machine learning systems these days. I don't even know if the language of computing that we all learned or we all were brought up with will be the same language they speak natively. So, it does make me wonder what the future of computing will hold for, I hate saying it, but the next generation of computer scientists, given that supposedly we're the next generation of computer scientists. But that language keeps changing, and the kinds of incredible tools and systems that are accessible to people who are relatively young keeps changing. And who knows, maybe I would have been a mechanical engineer 30 years ago, but this is what happened to be accessible to me and catch my eye now.
Cool.
Yeah, like, oh, go ahead. Well, like Megan, I mean, while a preschool teacher, we attended, all these preschool teachers in the county, we attended this conference on brain science for early childhood educators. So how can we take the latest brain science and help that inform our teaching? And so that's what got me interested in research. So day one of my undergrad, I was working in 2 research labs. The only reason though that I attended undergraduate college that did research was because I got this small scholarship that made me feel like, okay, I could attend this more expensive public, university than attending maybe continuing to attend community college. And so from day one, I started research, but I wonder right now, what if we hosted a conference for early childhood educators on, computing research and some of the latest things happening with educational technologies and how that might inspire and bring a lot of early childhood educators into the field.
So I'm another person who was first exposed to computing research through undergraduate research. It's super important. In high school, I started reading a bunch of lay person's books about particle physics, and they were going to turn on this Large Hadron Collider, and I'm like, this is so cool, I want to be involved in this. Or just particle physics was really capturing my interest, and so I started working in a particle physics lab. And something that's super cool about particle physics is if you do computing in particle physics, you're technically, I guess it's both on the experiment and the theory side, but computers are so important for basically modeling how your detector is going to interact and stuff. And so I've got a lot of experience with Fortran during that first experience. I had to understand what a punch card was and why my code wasn't compiling because my line was too long. But that was really, but more seriously, like that was really when I learned, wow, like this is actually what doing physics is like. It's not taking the classes and stuff. It's really trying to get a handle on the world and how to probe it and how to model your experiment and things. So that was my first exposure.
Wow, it's really interesting the importance of that exposure to research as undergraduates to sort of move you on that path. That's really interesting. So why don't we move on to a second question here? And I heard several of you talking about sort of, I guess I want to say the people side of things, being able to help people, health concerns, and that being a motivating factor. So here's a question for all of you to think about a bit. So you're at this wonderful position, you're sort of sitting there, you're looking forward, the start of a career, you're at an amazing place. And I guess the question to you all is, what's important to you as you look forward? How do you, and maybe you can think about it along 3 different dimensions. What do you think about the values that are important to you and how they're expressed through your work and the problems that you choose to work on? Some of you talked about that already. And what kind of opportunities and experiences are you really looking forward when you're looking forward?
So for me, I think it's the main value that I look for is the trust in the system. So anyone who's trying to use the system that we as computer scientists or computer engineers have built should trust it. And by trust, I mean, no matter what their input is, they trust that whatever the system is doing for their good. So how can we ensure this whole, and trust is a complex thing. Like it could mean fairness for you. It could mean that the system should explain what it's doing for you. It could mean that it is robust to different noisy inputs. It does not generate any chunk output, whatever you give inputs. So trust is a very overloaded term. And that is the main goal that I have, that I want to make sure that anyone who is using trusts it and can make the most out of that, whatever the data they have. And that is what drives me.
Is there a particular, I don't know, set of experiences or opportunities that you're looking forward sort of in that context of trust?
Sure. So I can actually give a brief history of how I started working on this. So back in 2015, I came to the US. I started working on fairness, and how I started working was that I observed near me that insurance rates are very different for immigrants, and we thought, let's just test some insurance software to check whether it's actually true or not. And we observed that there is a lot of biases in the system that are there. Later on, there were many studies that came out online that showed biases in facial recognition and so on. So since then, I've been interested towards identifying such biases in system and figuring out why those biases exist. Is it the data that is the problem? Is it the machine learning algorithm that is the problem? Is it the person who's collecting the data that is the problem? Is it the person who's specifying what the system should do is the problem? So there are a lot of moving pieces, and everyone does not speak the same language. Like a social scientist speaks a very different language from a computer scientist.
Yeah.
And most of these systems are being used by social scientists because they are the ones who will deploy it in the real world, or the bank will deploy in the real world, and they don't speak our language. And what we speak is just mathematical formulation of fairness, just implement it and test it. But in practice, that is not true.
Mhm.
So we need to come to a common ground, working with social scientists, economists, to speak the same language and make sure what they understand as trust, fairness, explainability, we need to speak that language and make sure our computing goes in that direction.
Yeah, I so much of what you just said, I want to echo, and I feel as well. I think when I work in security and privacy, and so when it comes to values, it's actually just like right there on the label, right? And the values in my work, I'm very lucky, can be put forward very easily. Although, you know, lots of the field works in security and privacy and does that in different ways. You know, security and privacy, as I see it, is about people, but oftentimes it can be about military stuff and whatever, right? But and I think being able to carve out, you know, here are my politics, here is who I am, and I'm not afraid to imbue that into my work because it's how I see and understand what I do. That's really important to me. And I think what's part of that for me is that when you say security and privacy, without people, it doesn't really mean anything. You know, privacy doesn't exist as an abstract, right? It exists for individuals as they experience their lives and as their data flows around the world. And because of that, like for me, the kind of opportunities and experiences that I'm really excited for and looking forward to throughout my career are ones that actually have to do very little with the core computational work of security and privacy. It's the opportunity to go and be with other people doing other research and being present in their work, present in their language, which you just said as well, that like building that shared language and that shared vocabulary, those shared ideas is fundamental to doing work that ultimately is about having people have more privacy, have more security, right? I can't just give them a box and say, okay, put this box over your head. That doesn't work. It doesn't work for them, right? Instead, you've got to go say, okay, well, what kind of security do you need in your life? What are you missing? What do you not even know that you're being surveilled? Like, do you know what's going on in your life? Do you want to know? If not, cool, right? If you do, let's talk, right? And it's about building those connections. And I'm really excited for the expanded borders of computing to include more people coming into computing and more people from computing leaving, you know, the bubble, and having those conversations. And yeah, I guess I said this earlier as well. Like the boundaries of computing don't really exist for me. It's just kind of where we all live our lives now. And so it's really about talking to folks who don't think of themselves as computational people, but secretly they've been doing computational work their whole life, and research their whole lives.
Yeah, to take things, I guess, to take values in a slightly different interpretation, just to change things up, a lot of my thinking these days is on what constitutes knowledge. You know, what do we take as acceptable knowledge in computing and in computer science? In many ways, that's how we draw the boundaries of what is and is not computer science in terms of our field. There were certainly departments I interacted with during the faculty hiring process where if you could not prove it, it wasn't considered knowledge in computer science. And you know, you can imagine how many or most of the people who are currently in this panel would not be considered computer scientists by anyone who held that view, and their departments reflect that. And, you know, as a field, I think, you know, whether because, you know, we're all young or because we were hand selected in that way, we're all looking outwards and we're all challenging those notions in the way that we go about our work. But, you know, for me, it's a very simple one of, you know, is the natural science view that empiricism, you know, is a form of knowledge, is that acceptable? For many of the folks here, it's even pushing more broadly beyond that in terms of how they look at their work. But, you know, at the end of the day, you know, I think that is values-based to some extent in terms of who we want to be part of our field and how big of a tent we want to have.
I want to follow up on that a little bit, Jonathan. I think that there's this kind of interesting dividing line between where computer science has come from and maybe where it's going. And one of those is that for a very long time, a lot of computing research has been focused on saying we've got these building blocks that computing can allow us to build interesting new things with, and we're trying to kind of put them all together and prove that we're building new systems on top of that. And we've created this incredibly complex system that has infected every part of our lives for good and for bad. And the result of that is that we now have to study the thing we made. Like, we're all individually building all these little blocks, and then no one was really paying attention to the castle we're standing on, or the one that's made out of quicksand. I think you said that earlier when talking about machine learning. And so I think that's really a lot of what has interested me in this space. And in particular, I think a value for me is inclusion. We don't really, when we look at all those building blocks, we were probably not very consistently considering who was being included in building those blocks, who was being included in using those blocks. And this means that we've built this really important organism across our entire societal lives that we don't actually have an equitable way of distributing or a way of helping other people be included in. So I think that's a lot of the focus. That's for me why I focus on disability a lot in my work, but I think it expands beyond that.
So Simon talked about, social scientists and collaborating with social scientists, and Gabe talked about people and, making the tent bigger, but also leaving the tent ourselves, and, Megan with inclusion. And the words that I keep thinking about is multidisciplinary, cross-sectoral, cross-sectional collaborations. And, so I'll give you an example. One of my classmates, PhD classmates at the University of Colorado Boulder, she got a fellowship, and this is the importance of funding. So funding ideas and giving people money to do neat things. She got a summer fellowship to work with the Colorado state government. And so she worked with a state congressperson, and they developed this new bill on artificial intelligence and facial recognition. So it would establish a task force in Colorado, an interdisciplinary task force, and it would put some restrictions and regulations around the use of facial recognition in criminal justice and K-12 education systems. And so then when it went to the Colorado Senate committee to, see if they wanted to pass this, we were invited, and a few of us testified as well. And I spoke from my perspective working with the National Head Start Association, which funds preschool programs for low-income and disabled kiddos across the United States. And we've been working on AI ethics for early childhood initiatives. Same with UNICEF globally. And so it was just so amazing, and I'm so proud of her. And that inspired me to see the importance of computer scientists and people with our training, collaborating with governments and collaborating with bigger organizations and institutions to get our knowledge and understanding out into the world and to actually influence change in action. But in order to do that, we really need to be collaborating with each other. And that's something that I think about so much throughout my education and now throughout my work is I'm not so interested in competition, and I'm really interested in collaboration. So I don't want to compete with my peers. I want to collaborate with my peers. I don't want to compete with other fields. I want to collaborate with other fields. And so those are just two of the values that I'm really focused on.
Wow, that was well said by everyone here so far. I think they covered the bulk of what we were maybe trying to answer with this question here. And I like Lane's point when it's collaboration and not competition. That was one of the things that led me to pursue my PhD at USC because there were so many opportunities to do interdisciplinary work, on that research level. But for me, I guess when I think about this particular question, I also want to maybe echo the same sentiments that Gabe had, which is we do want to focus on privacy quite a bit, and I'm coming from maybe the health perspective. Privacy is a big issue, especially among consumers and other users of health applications, and other traits or other aspects that I'm looking for within the ethical implications is accountability of who, gets maybe, I hate to say gets the blame, but who will be held accountable in situations where some of these systems may go awry. And in the healthcare setting, transparency is a huge one, issues of explainability of the system, and also permissions, who gets permission to do what with some of the applications there. One thing I have noticed when talking about anything related to computer science, artificial intelligence, robotics with the general public is that for the most part, with people who are outside of our research area, the conversation usually almost always goes back to ethics and the fundamentals of what we are doing and how will it impact them, not now, but also in the near term. And many people are very interested in ensuring that there's equity in the systems that we're deploying, that they aren't going to harm certain demographics, unfairly and harm people in the long run. And I think that needs to be a discussion that we just have now and in the long term. And what I'm starting to see now within the field of computing, which we probably haven't seen in maybe the past few decades, is that a lot of organizations and institutions like universities are starting to put ethics at the forefront instead of at the back end. So we're now seeing some universities actually, give freshmen ethics classes before they actually, get into the hardcore programming, so that they can start asking the question of, who will this technology potentially work with? How can it potentially harm someone? How can it do good? And ask those fundamental questions. And I think we can all recall that the quote from Jurassic Park, which I think kind of echoes this as well, which is, it said that your scientists were so preoccupied with whether or not they could, they didn't stop to think if they should. And this is something that, I want to see as a value carried out through the field of computing for as long as I'm a researcher and beyond, is ethics becomes more ingrained within us, or the understanding of it. It becomes more ingrained within us to the point where one day we may not have to have a separate ethics department, where it just would become natural for us to ask the questions while we're building the technology or while we're filing the patent. And that's my long-term goal. And as far as experience and opportunities, I have to be honest as well with Jonathan. I'm a techie at heart. I'm a scientist, so I do enjoy just the basic fun of tinkering with things. And so I do want more opportunities for anyone and everyone, regardless of their background, regardless of their demographic, to be able to jump into computing and be programmers and software developers or roboticists, hardware engineers. I want them to have that opportunity and that access and the ability to achieve an education in this if they choose to. And I believe that starts with us, and we can just have more conversations like this and get more people interested in the work that we do, and provide pathways and avenues for them to jump in and contribute to the space that we're contributing to today.
Wow, it strikes me that almost all of you have a geeky side, and yet I've got to say, you come across as 7 of the most social and people-oriented people that I've had a conversation with like this. And you talk about people using your research, and your research being for people's use, talking about being inclusive of who's part of a research community. You've talked about people working together, interdisciplinary, collaboratively, and ethics. So I've got to say, it's sort of neat. I don't know if it's a yin and a yang to see sort of socially oriented people with totally geek sides to them as well. It's just an observation that I want to make there.
Jim, I think that's something maybe that some of us have had a bias against throughout our development. So folks who have been more social and personable and have other skills and traits and interests have sometimes been discouraged, or even not viewed, like our geeky side, our technical side, our tinkerer side hasn't even been, it's almost not been observed by others, because
sort
when
of
they
latent.
see us,
yeah,
when they see us being social, they think you couldn't be that way. Whereas, being social is the same thing. I mean, humans are, extraordinarily complex systems. And so people who have dove into figuring out humans and how to communicate and how to nurture and support are people who are really interested in extremely complex systems.
Well, I always like to use the phrase computing being expanding and expansive. And I think all of you, just from these conversations, it's so clear how you're all out on those expanding boundaries and working in different disciplines. And honestly, many of them seem to be intersecting with the social sciences, really quite a bit, which is really cool. Tess?
Yeah, so I mean, I can maybe add some perspective on maybe the physical sciences point of view. So I value a lot of things that have already been discussed here. I mean, I think making our research environments more inclusive of different perspectives and different backgrounds, coming at things from, there's so many different ways to even look at the same topic. Certainly there's like, you can look at from, a physical system from one angle or another and like really get different intuitions about different things. And that's exceedingly valuable. So clarity and the ability to communicate across different perspectives is like super important. I think physics could use a bit more of that. There is a traditional way that we express the pedagogy, and I think computing provides, in many ways, if we build different tools for people to kind of play with physical systems, it provides another route, makes it a bit more interactive, makes the unintuitive intuitive. So I think there's a lot of opportunities there to have more people part of the discussion for modeling and designing physical systems. How do we design the world around us such that it satisfies the strict design critic of quantum mechanics? I'm very interested in how we build those tools. How do we build tools that can take our mathematical priors and also show us, like, help us figure out all the consequences of those things? Because just because you state your assumptions doesn't mean you have any idea of what that means later down the line. I've got neural networks that I've designed that won't train, not because they're not good at their job, but because I asked the wrong question. And it said, oh, you wanted this? Well, did you know there's actually these 5 options? And that's based on the assumptions that you built into me. So I'm really interested in creating systems that help us do a better job thinking, avoiding these pitfalls and biases that we might have, even if it's a mathematical bias or a physics bias. But yeah, echoing, I think what everyone said here. I mean, there's so much work to do on kind of increasing the people who are able to participate in these powerful modes of expression, and kind of directing where do we take all this computing power? Where do we want to take the future?
So another way how I'm thinking about it right now is that no matter what you think, you can apply computing there, and you can try to use it as a very fast computing brain, which could do whatever you want it to do. And now, since computers are being used in different applications which impact us on day-to-day basis, there is progress that's need to be made on every front. We need to develop regulations from the government side to make sure the computing is done in a responsible manner. People are not using it for the wrong thing. Similarly, we need to train junior undergrads. Like when I was an undergrad, I was not taught about any of the things all of you are working on. Like I just knew that machine learning is something that you could use to solve problems, maybe predict, that's it. And all the problems that you're working on, I was introduced when I was in grad school. So these are relatively very new areas, and we need to pass it down to junior undergrads, expose them to these different areas, maybe work with interdisciplinary departments and teach students how they can go into these. And these are different sides of computing that they need to be aware about. I think most of the engineers right now are not aware about these because they were not taught about all these things when they were students.
Right. So, this has been such a great conversation. Let's keep going though. And it was one of Jasmine's comments that made me, I think, wrapped up a lot of things that we're sort of imagining for you in asking you to be a part of this panel. And that was that you didn't know you couldn't do it. And so here you are, you've accomplished these wonderful things. And I hope you continue to feel that way going forward, right? That you feel this boundless space to conduct the work that you want to conduct and that you feel the world needs, because I think you are the response to what's been happening and where we're going. But to the extent that you're now engaging with more formal structures of industry or academia, are there any challenges you're starting to face or that you fear you might face in the work that you want to do that you think needs to be done? Maybe those challenges are intellectual challenges, maybe they're structural in some way or some other type. But I'd like to hear from you what those might be so that our audience can think about that as they return back to their places of work and try to imagine for you what kind of environments we have to create for this kind of computing to continue. Who'd like to start?
I'm happy to start with a very simple plea, which is hire people like this. It sounds really dumb to say, but most of the people who are here, I can think of several departments out there I know of off the top of my head who wouldn't consider these folks computer scientists and would not consider them. And, you know, whether we decide that computer science is going to look inward and some other discipline will embrace folks like this, or whether computer science will embrace these folks and will really make them fundamental to computing, really is a question right now. And, you know, I have it relatively easy that I can pitch myself as a straight down the middle machine learning person if I need to. Many of the folks here are doing work that is so interdisciplinary, you know, they couldn't get away with that if they wanted to. And, you know, hire these folks. I think at the end of the day, you know, we will be weeded out of the discipline if we're not careful because we're pushing the boundaries.
Yeah, maybe I'll build on that as well. I think there's two things that really come to mind, and the first one does have to do with hiring, and I think that is seeing breadth as value instead of a weakness. And you know, I had a job search last year. I did a limited search. It did not go great. And I kept on getting the feedback over and over again that it's like, oh, you're doing too much stuff, right? And it's like, no, I'm not doing too much stuff. I'm doing one thing. You just see it as horizontal instead of deep, right? And that was really, really frustrating because in order to be deep, you also have to be broad. You can't just be, you know, I'm an expert in exactly one thing. That's awesome. I'm so glad there are parts of computer science where you can be that, or computing where you can be that. I'm so glad. It'll work for some people. It doesn't work for me, and it doesn't work to expand the boundaries of computer science. You have to allow for breadth to be seen as a strength. The second kind of major intellectual challenge that I see kind of coming at me like a train that I'm really nervous about, but you know, if this is the place to share it, right? There aren't any other places I can share it publicly. So here we go, right? I think there's oftentimes a values misalignment between the research you're able to do in academia and what is seen as the value of computing outside of academia. So in particular, what do I mean is that if you work in security and privacy, oftentimes the things that I want to advocate for in this world are not great for businesses. They're like, here's more regulation. Here's less data that you can see. Here's less things that you should be able to do, right? And that's not great when you want to raise money in order to do your research. When you want to go to NSF, you want to go to DARPA, they want to say, hey, where's your tech transition? And I want to say my tech transition is I didn't transition any tech, and I stopped 6 companies from transitioning their tech. Right? That's a really, really hard sell. And it's not one that I look forward to making over and over again. And I'm really excited to try until I'm sure it'll fail. And that'll be great because I will have like shot my shot and tried my best to make that change. And I really don't know what we're supposed to do. Even earlier today, I was tuning into one of the earlier panels, and it was a really, really cool infographic about individual research fields that went from being in academia to then being a $1 million market to a $10 million market to a $100 million market. And I just sat there with like a deep anxiety being like, okay, what if I want the market to get smaller? Like, where is my infographic for that? And it's really, I think, you know, and maybe this is like a little too pushy for this, but, you know, there's a lot of machine learning folks in this crowd. Machine learning oftentimes is powered by surveillance and is powered by oppressive systems and is powered by extraction. And, you know, we're going to do machine learning as a community. It's happening, right? And I feel confident that people in this room are cognizant of the systems that are embedded and the values are embedded in their systems. But that's definitely not true everywhere. And there's a lot of people who are just like, you know, let's build a bigger model, let's get more data. And that just, and I can't sit with that, and I can't sit happily. So somehow trying to figure out how to do the research you want to do without immediately having like, here's my proposition for why you should let me do my research because it'll increase the US GDP, right? It's so easy to make that argument. And I want to somehow try to figure out how to make a different argument within our communities.
Yeah, I agree with a lot of the things that Gabe just said. So I think kind of on a related note, yes, sometimes, and I don't know if this is like, I don't know if I have advice to give kind of to the folks out there of how that they can help kind of foster more folks like us. But one issue that at least I face, and I suspect many people on this panel face, is that folks try really hard to put us in a box. Like, oh, you're this kind of person. I know what you do. And then, oh, you're this kind of person. And what's really fascinating is when I go to a conference that's kind of focused in one area, they always think I'm from that other field. But then when I go to that conference, they think I'm from this other field. And this goes on forever. There's actually a lot of great things about this, especially like for writing grants. Like everyone thinks that you're going to be useful to their proposal. So that's really nice. But when it comes to setting milestones for like, okay, what is the community that's going to evaluate you, especially with relevance to tenure? Like, have you made an impact in field X? And it's like, well, what is my field actually? So there's a little bit of an existential crisis that maybe others also feel. I don't think it's necessarily a bad thing. I think I think it's an important thing to figure out. But I think just being cognizant that, yeah, some of us are just not really it's gonna be hard to pinpoint where it is. And maybe it's on us to kind of brand ourselves properly. There's a bit of that. And then, also you might be in a field where like Gabe was saying, you don't necessarily align with maybe the main values of that field or adjacent fields or the industrial side of those fields. So for example, like I interact a lot with the ML communities, but culturally I'm very much a physicist. And so I really like to publish very few papers. And once I do, I want it to be very intuitive and give some insight on something. Like proofs are nice, but it's much more the intuition perspective that I really like to put forth in papers. And that just really doesn't jive with a lot of like the proofathons on some papers from CS side of things. So those are maybe just some perspectives of maybe what it's like to be us, if I dare speak for the panel.
I have a kind of similar feeling to you, Tess, particularly, and maybe in some ways it's also the opposite. When I'm often find myself into more interdisciplinary spaces. I can imagine like being at a conference while I was on the job market, and someone came up to me who knew me from another area of my work, and they're like, I didn't know you did all of this work on healthcare. And I'm sitting there thinking, more than 80% of my papers are in healthcare, but they thought of me as a knitting researcher or a manufacturing researcher. So is that kind of like, sometimes you end up having to publish and talk about pieces of your work in the places that they are most salient. But then this creates this kind of knock-on effect, particularly for systems researchers, where, okay, you've published all these different pieces, or you're building on other people's work. And so the novelty of all those pieces is no longer existent. But that overarching thing is still novel, meaningful in some way. You had a plan from the get-go that this mattered, and this was all going to be put together, and now you can't really get people to kind of look at it in that more holistic way. So I think that's a real challenge for both the kind of practicality of having a career in this space, where we're being measured on the amount of publications we get out there or other types of things. But it's also really hard to have the two kinds of conversations I think are interesting. One are the really nuts and bolts of kind of the detailed bits, and then having the separate conversation about how this all goes together, that I think is really going to affect more of that kind of complexity of this organism of computer science.
All right, I'll follow up with that as well. To this question, I've kind of found myself currently, and in the past, I've found it, kind of beneficial to be in all worlds, which is, industry, academia, and also in, the startup landscape as well. I see kind of benefits into doing science in all three of those sectors, also in the government. And, one thing I would like to continue to see moving forward, and that I have seen in the past, is maybe removing barriers within the collaboration of all of those spaces. Many people from academia feel like they can't maybe accelerate some aspects of their research because of whatever they may feel is holding them back. So they may start companies, or maybe form alliances with industries so that they can get their tech and transfer it out to a product that's something that could be used by the public. So I would like to see more collaboration on that part, personally for me. So that means support of tech transfer programs, democratization of various AI tools or software tools or computing tools and resources. And that could also mean various access to the access and interpretation of data sources as well, and various models that people can use to study and use in their research. I think that will push the field forward when everyone could have a chance to iterate on some development there. I did see a question pop up. I didn't know if we were supposed to answer it or not. It was related to what structures went into building us up to, or let me see if I can actually rephrase it here. Pushing the boundaries of interdisciplinary work, what allowed you to be that way when you were students? I will say having various platforms and avenues and outlets, like we mentioned earlier in this conversation, for many of us, it started when we were in middle school. I remember vividly of joining a girls in technology program where for the summer we took various field trips to learn about tech applications, and having that even in high school. I went to a school that I was not zoned for because I had a technology and engineering magnet program, but having that throughout my childhood consistently was the reason why it reinforced me to be where I am at today. It wasn't just a one-time thing. It was a support system that was always there. No matter what school I went to, my family ensured that I was engaged in a program that would facilitate where I am today. So I would say that goes along with the structures that we can look at where we are as professionals and start looking at what structures we can continue to facilitate and foster for the youth to ensure that they can do bigger and better things than we are doing currently.
Jasmine, you have been consistently talking about structural things, right, that we can do to change, our current system, and also to amplify the things that we're doing. And on that question about how we got our start, for me, it's funding, right? So when I was teaching preschool, it's not a lucrative career. So my adopted grandmother, she, gave me money to pay for community college classes. And then I got a certificate in early childhood education from the community college, which allowed me to transfer into the University of Colorado Boulder. But I was scared. I didn't think I could afford going to that school. And then I got a really small scholarship from a local organization. And that gave me the confidence that, okay, if I got one scholarship, I can get more scholarships. And I mean, similarly, in order to do the research that I do, I don't think that I would be doing this research if I hadn't been awarded a PhD fellowship, a 2-year chancellor's fellowship to start my PhD research. And that allowed me to dream. And I thought, okay, I don't have any constraints. I get to think about what I want to do. And that allowed me to go back into my past. And my PhD advisor really encouraged that. He said, hey, I don't want you to think about the research. I don't want you to read research papers. I want you to think about yourself. And I want you to think about what are your keywords? What are the things you care about? And he said, I'll get you started. I know you care about young children. I know you care about brains. I know you care about at-risk youth. And so he kind of gave me some keywords and that allowed me to dream. And I thought back to my time as a preschool teacher. And because I had that fellowship, I was able to start tinkering and experimenting, which I wouldn't have been able to. And then, of course, getting the NSF GRFP fellowship allowed me to really focus my dissertation on these ideas that I just wouldn't have known that there was a space for otherwise. And so all the time when I'm in diversity and inclusion committees and people talk about how do we, support X group or X population or X demographic, I always say, give us funding, right? Create fellowships, scholarships, give us funding to do this work, make it something that we can put on a resume or make it something that we can put in our livelihood. And similarly, I know at the University of Colorado Boulder, we built this new tunnel that goes from the computer science building to the business building, from engineering to business, and it's meant to really catalyze collaborations. But I think about what would it look like if we were building a tunnel between computer science and speech language pathologists, speech language therapists, between engineering and the humanities, right? So I think also about how do we support domain experts who are coming in from different fields and give them funding to do really brilliant work.
Following up with Lane's point about funding, I think funding is really one of the major things that need to be taken care of because grad students you always need funding to work on these new topics, and there's not a lot of encouragement you get from faculty. So in my case, I felt that I got the right set of mentors who were willing to explore these new areas with me. And when I pitched this new problem to them, and they were like, yeah, let's try it out. Let's give it some time. When we submitted papers, no one encouraged it, but we were working on it. We submitted a couple of times, and the next time reviewers liked it. And so you need to be working hard to make it happen. And I feel people are more open-minded nowadays. And I now consider interdisciplinary work as an opportunity to talk to multiple disciplines. So like if I'm working in two areas, I can talk to people from area A and area B both. So there's more of an opportunity. And nowadays, I think there are many other opportunities in the departments. Like, for example, at U Chicago, we have a data science institute where there are faculty from different areas like economics, psychology, social science, and computer science coming together. They have meetings and they have workshops where on specific interdisciplinary topics, where they invite all the students from the area and all the faculty who are the researchers working in those areas to come together, brainstorm on new ideas and how they can progress together as a field.
I'm reflecting on the fact that pretty much everything that we've discussed, to Lane's point, is very structural. And I'm asking myself right now, what can I do as someone who will eventually have a very tiny research group at a very big place? And how can I help to facilitate this without necessarily needing to change the way that the field operates, the way that the department operates, or the way that the NSF operates? Not to throw out yet another discussion and a loose end, but I would be curious to hear what folks around here think.
I think, tying both this, like, what can we do as kind of individual leaders in the field or organizers of smaller groups, and then also to the question that was from the chat about what was special about our programs or our PhD programs that support us in being this kind of interdisciplinary researchers. I think it really comes down to mentoring sometimes the strategies that we have found to work around the existing systems, and also a sense of kind of a moral authority that we have to change them when they are broken, when we have even the smallest opportunities. So I reflect, I was really fortunate in my PhD to work with a number of PhD students with disabilities across the board, neurodiversity, blind, deaf, different types of chronic health conditions. And we had to kind of work as a team to work around the systems that were making it difficult for us to access both our classes, our TA-ships, and certainly our research and the research communities that we're a part of. And that often reflected in choosing to take on more service roles at an earlier stage in our conferences that were most important to us, to make sure that the content that was being produced by those conferences was accessible, that the people who were working in them were accessible. And I think this was both kind of a necessity of working with the people I already had been working with, but also kind of met this value that I can't really honestly be working in a space of accessibility and supporting people with disabilities while not supporting the colleagues who are right just next to me in doing this work. So I think sometimes it's mentorship of the ways that we get around the system. And then it's also that saying, just because you found a way to get around the system does not mean that the next person needs to just do it your way. It means that we need to change that system whenever we see the small opportunities to do so.
One thing I've noticed that has been impactful in my research career so far isn't just having opportunities for interdisciplinary work within people in my institution or organization, but also the opportunity to talk to normal everyday people about my work and having conversations with people who aren't necessarily technologists or engineers. I have had so many, surprisingly, light bulb moments just from discussing my research with people who may be vaguely interested in it. And I think the reason why that is because as scientists and engineers, we're so focused on the fundamental technology of our work and how it works and how can we break it. But when you have the opportunity to look at it from a different perspective from people who are outside of your, not just your discipline, but outside of engineering, into other fields, you really have a chance to look at it a different angle and how you can improve on your work. So I think one thing that's another thing, in addition to what I said previously, in terms of barriers, is that we can also maybe do a better job at communicating the science of our work to other people and to the public. And I think this will be fundamental and also help us in return be better at ensuring that we're doing work that's impactful and influential to the people that it will eventually have an effect on. And I could use an example of the I-Corps program, which is, I believe, by the NSF. And it's a way to get technology that's in a university and turn it into a product that's eventually used. And it's like a 7-week program. And for participants in that program, they describe what it's like to go to do it and to participate. And usually what they have said is that, you know, they only get one time only to talk about their product. And that's on the very first day. Every other day after that, they talk about what it will be like to, they talk with people, their potential customer, the potential users, on how their technology could potentially impact them. And, you know, so I think with scientific communication, SciComm, if you want to call it that, I think it's a barrier that we can start digging at eventually, so that we can better inform people of our research and in turn see how we can be better technologists in the process.
So again, echoing many things that Jasmine said, really talking with many different folks of different backgrounds. In my case, many different scientists from very different areas was hugely influential into how I view my research, what research I find interesting, because these people with different perspectives would, you know, they would teach me about the types of areas that they were interested in. A huge structural influence was the fact that I did my PhD at UC Berkeley. And I spent a lot of time actually up at the National Lab, so Lawrence Berkeley National Lab up the hill. This was really huge for me because there's a bunch of user facilities where a bunch of folks from around the nation will come and use our facilities at Berkeley Lab. And so I got to meet just tons of folks who were doing really interesting things. I would interact with the folks at the National Center for Electron Microscopy and learn about those types of problems as the molecular foundry, learning a lot about how do you do synthesis on proteins versus inorganic structures, organic stuff. It's like all stacked in the same building, to the National Energy Research Supercomputing Center. So, you know, there's a lot of these really big resources that are open to researchers in the US and beyond. And just the opportunity to have them all in one place and getting to run around and talk to everyone was just tremendous. It totally shaped the trajectory of my research. I am now on grants with people who I met as a graduate student, and now we're all PIs. And so we are able to kind of band together and do something really cross-cutting. And so that's really exciting. So having those institutions where you really do have all this expertise blended is super, super important and was very valuable for my career.
Thank you so much, everyone. You're just all so inspiring. There's so much left to discuss, but we're running out of time, and we wanted to leave you a little time to give some closing remarks. Anything you want to say that you couldn't say, any take-home ideas you want to leave with our audience. This is your chance, and we'll start with Gabe, please.
Yeah, this has been really inspiring to be in a community of people, even if it's one that's virtual and limited in time. It's really been fun. The two quick things that I think I just want to say one more time is seeing breadth as value and not as a weakness. I can't say it enough times. It's so important. And the other thing is that Megan really this use of calling computer science an organism is something I'm definitely going to carry out of this and be using. So I'll try to give you props every time I say it, but no guarantees. I might forget. But it's so true. And I find myself increasingly just wanting to study what is this organism that we've created? What does it do well? And what does it do poorly? And what are we doing to shape it so that it's not going to destroy our society and it's just going to make society better?
All right, awesome. I just want to thank all of the panelists and hosts for this engaging discussion. I've also learned quite a bit from you all. So I want to thank you for the insight that you provided. And to everyone listening, this is an opportunity for us to really change the trajectory in a positive way where the field of computing is going. I think it can head in a wonderful direction. I'm very interested in contributing and participating in that as well. So I just wanted to, I guess, leave with a quote. Many people that are listening, especially the youth, they oftentimes think that people like us are just so ridiculously smart that, doing this work, it can't be achieved. But I just want to ensure that oftentimes we just started out with the wonder and excitement of trying to make a contribution, trying to do something positive, or just, like Jonathan mentioned, just having fun building things. That's how it started for many of us. So I'll just leave you all with a quote from Donald Knuth, which, kind of echoes, it says that people think that computer science is the art of geniuses, but the actual reality is the opposite, just many people doing things that build on each other like a wall of many stones. And I think we did that here today. We built on each other, all of our collective knowledge. We had a hive mind. So I'm very grateful to be a part of this. Thank you.
When I think about the future of computer science with a capital C and a capital S, which I acknowledge is different than computing necessarily, this is a moment where I think the field has to make a pretty big decision about whether it's going to look inwards and not embrace basically the kinds of folks that you see right here, in which case, we will either need to find other intellectual homes or find no home. And, maybe these intellectual directions will never really find their home in academia. And I think we're at a crossroads in that respect. Are we going to look inwards or are we going to look outwards? And, I sure hope it's outwards. I'm not always heartened by the experiences I've had in my own home departments in that respect of the places I've been, but I like to hope things are changing, and I hope, for those who are listening and have the power to make that change, they will see the opportunity.
I've definitely focused a lot of my life on, what's in my locus of control. So focusing on, my individual self and changing myself to kind of meet the needs that I see. But right now in the field, I've really been realizing that it's about systemic change. And so we really need to advocate less about what our needs are, how we can serve our needs as individuals, but how we can advocate for systemic change. And a quick story, I collaborated with the National Head Start Association to create fund a hackathon track on early childhood. So we put up prizes and mentorship and funding for this early childhood track in a college hackathon. And what happened was half of the students ended up designing for early childhood and winning prizes across the board. And that really taught me that if we fund new innovations for students, then they'll really catch on to that and find their own, passion for it.
I really just want to thank everyone here. This is a pretty major transitional point for me in my career, and it's kind of interesting sharing that moment with each of you and thinking more broadly about the space that we're fitting into. I think for me, it's really saying that computing, a lot of the time we've been thinking about ways to make life easier or to build and enable new things, but we've actually made this very complex system. And so maybe the future is more thinking about reckoning and dealing with that complexity and the interesting opportunities and challenges that it's going to face us.
I had a great time talking to all of you, and the way I see computing is that we are in a golden era where you can do whatever you think of. So I would say think big, try to work towards your vision, and try to collaborate with whoever you can to achieve that vision.
Yeah, echoing what a lot of folks have said, this has been so much fun. Thank you to the organizers and to all the panelists. I've really enjoyed learning about kind of your ideas, your trajectories and everything. Super inspiring. I also kind of want to maybe give a big thank you to the many different institutions that I feel have fostered computing in my personal career. So whether it's like kind of the Institution of Particle Physics and using computing to explore the mysteries of the universe. Also, like in grad school, again, Lawrence Berkeley National Lab, and just all the beautiful mergers of the sciences and computing, and really seeing no boundary between any of these. And then also at MIT, we've got our College of Computing, we have our computational science and engineering programs. And so I feel like these were all places where I felt like I could actually risk a bit, try something that was maybe a little bit not what others were doing. It was always scary at times, but ultimately I felt supported even as I was struggling and kind of through my maybe research adolescence. So just that support. So if you're hearing this and you're in a position where you can be supportive of someone exploring something that you're not really sure if it's going to turn out because it maybe seems a bit unconventional, I think just giving that support is tremendous, and I think you'll see a big payoff. So yeah, so thanks everyone.
Okay, great. And with that, we're going to really need to close out this roundtable discussion with a great note of thanks to this really fabulous set of roundtable participants. As Laisha said, you've all been just really, really great. You know, a comment came in from the Q&A, quote, "Not a question, just an observation. You panelists are all fabulous. You give me hope for the field." And so I'd say truer words never spoken or never typed into a chat window. So it's really been a fabulous discussion. I'll say, if you're watching this now or you're in the future sometime, for people who like Star Trek and like to think about that, and you're listening to recording in the future, tell your friends and colleagues there's ways to come back and other people can look at this. I think there have been a lot of really insightful thoughts shared here. And so to our panelists, we, and I'm sure everybody else who's out there now and in the future participating in the symposium, wishes you all the best.